Hey there, I wanted to record a video on a slightly harder domain problem. So for example, this one, find a domain of the function. And we have a radical, right? This is an even root. So if you had a square root, a fourth root, a sixth root, you will do it the same way. So what we know about radicals is that the inside can't be negative. So the inside of the radical can't be negative. So that means that we want 3x minus x squared to be greater than or equal to 0. And so we gotta solve this higher order inequality. And so how do we solve a higher order inequality? With higher order inequalities, right, this is not linear. We have a quadratic. So we always have to factor first. So what can you factor out of here? I can take out an x and I'm left with 3 minus x greater than or equal to 0. And now from here, the mistake that you want to avoid is you don't want to say x is greater than 0 and then 3 minus x is greater than 0. That is not how we solve higher order inequalities. So from here, what we will do is identify the zeros and plot them in a number line. There are a number of ways that you can do this depending on what was the method used in your previous class. I tend to use the test point method. So identify the zeros. So what makes this quantity 0? X is 0 when x is 0. So, and 3 minus x is 0 when x is 3, right? So doing the equals part, we get our zeros are x is 0 or 3 minus x is 0. This one tells us x is 3. So at this point, we have those are when the function is 0, the product is 0. Now, because we are looking at greater than, that means we want things to be positive. So that means that whatever x is times whatever 3 minus x is has to be a positive number for us to be greater than or equal to 0. So let's try some test points. So pick something in this interval. So this is the interval minus infinity to 0 and less than or equal to, so we would include this interval. So pick something in there. So let's pick x equals -1, for example. And so you're going to have -1, right, x times 3 minus x, 3 minus a -1. So what is this? So we're interested in the sign. So this is negative, and 3 minus a minus becomes positive. So this is you have a negative times a positive, which will be negative. So do I want that interval? No, right? We're looking for things that are positive. And now pick a test point in the next interval. This is the interval from 0 to 3. Since I am including, right, I have the equals. If this function had the radical in the denominator, then I will not include those values. So 0 to 3, pick something in there. Let's pick 2. And do the same thing. So x times 3 minus x. So x is 2, and then 3 minus x, 3 minus 2. So you're going to have, now you're going to have a positive times a positive, which is positive. So I do want that. So I will shade here. So we can shade right away. And so now something in the last interval, this is the interval 3 to infinity. So pick a test point in there. So we can pick x equals 5, for example. So then you're going to have x, which is 5 times 3 minus x, 3 minus 5. And you can already see 5 times a -2, that's going to give us a negative, which we don't want. So our solution, or the domain for this function, will be the interval from 0, shade all that, all the way to 3. So we can say the domain is the interval including 0 to 3 included. So that's how you solve a domain problem like this. Whenever you have to solve a higher order inequality, make sure that you factor first and then use a number line or whatever methods you use in your prior class to solve higher order inequalities. So a similar problem you might see would be something like, say, f of x equals, I said the square root of 9 minus x squared. But in this case, I want 9 minus x squared to be greater or equal to 0. And now here I would have to factor. and do the same thing to a number line and plug in your test points. Hopefully that helps for these harder domain problems.